So we're gonna do or just talk about the start to firewall stuff. So I went through the little survey things, and it seems like there's a happy little mix of some folks have played with firewalls and some folks haven't. So it's almost like a 50-50 shot. So that's cool. So the Windows firewall is more like a 60-40. Some have played with it. Others just turn it off if it causes you grief. So that's cool too. So we'll tinker around with those. So today we're going to go through like kind of the decision process we make for segmenting a network, like why we put things in certain places over others. And we're also going to talk about kind of the layout of networks when we're doing firewalling and stuff like that too. So we're going to do that, and then what fields firewalls are looking at and stuff like that. So that's going to be our basic stuff, and then some really generic sort of firewall syntax. Because this today will be like making firewall rules on paper sort of thing. Every device kind of has its own weird syntax and stuff like that, so there's not this like one golden standard for the way firewall rules should look, but we'll get pretty close. So why do we segment off our networks? Or like, what is segmenting? Yeah. Either one.
It's when we break off a certain part of the network from another, so it can't really interact too much with the other.
Yeah.
And so then do that if one of the parts goes too far and it doesn't affect everything.
There we go. So we split our network up into multiple pieces, so that way the bad things going on in one area don't impact another area. So makes sense. There's a lot of ways that we can pull segmenting off, though. So generally, we're going to use some sort of firewall. Can we segment with a router too? We can. Routers aren't so good at doing the whole ACL game, but they can do it. So that's going to kind of come into play when we start talking about how we actually lay out our network, like the topology and whatnot that we should have. So the decisions of how we actually decide to segment stuff is always, I don't know, it depends, right? So some places will actually do network segments based on department. So if you are a developer, all of the developers in this organization are on one particular subnet or one particular VLAN or accounting, stuff like that. What makes doing it by department really kind of hard sometimes, or can make it difficult?
Because a lot of like really small departments, so you don't have a lot of people on one subnet or one.
Oh, sure. Yes, if we're not a really big organization, maybe the accounting department is 2 people. So we're going to have a subnet for 2 people? Maybe, I guess. That's going to be kind of annoying to manage. What about on the opposite side of that spectrum? What if they're huge? Or go ahead, John.
Well, they also want to talk to each other. Like if you need to, one department needs to actually talk to another network or another department, that's going to be an issue.
So then we have to decide like the rules of how the segmenting works, because if we want to allow the accounting to get out somewhere, and that's going to really, really complicate this, because maybe accounting needs to talk to developers or something weird like that, right? What if we're a really, really big organization? Are all of our accountants going to physically sit in the same spot? No. Like, what's the biggest company anyone's worked for? You have like a ballpark? Like how many people? A couple thousand? Yeah. So that's my biggest, I think, was like about 7,000 people within a company. So when you go to talk about the accounting department, well, there's like accounting had like people on every floor of every building, because if you're a salesperson in an organization that big, you have enough sales stuff going on, you need to go talk to the bean counter every once in a while to make sure you're not like undercutting something, right? So if we have things that are geographically dispersed, that's going to make it not impossible though, right? Because we could still VLAN it all together so that users get put on appropriate VLANs and whatnot. And there's easy ways of actually doing that we'll talk about like kind of later on. Normally, if we were going to VLAN like all of you and put you on appropriate departments on this one single switch, what am I going to have to do to get everyone properly segmented? If we have one switch sitting up here and you all plug into it, and let's say there's 10 different departments that everyone works in, what do I, as the IT minion, have to do?
So everyone plugged into that switch?
Yep, everyone plugs into the switch.
Different department?
Yep. Yes, that's what I'm going to get to later on. But without that, I have to figure out what department every person is, and then somehow trace back each port that you've plugged into to you. So I know that port number 3 has to be configured for accounting, and port 4 has to be configured for developers and all that fun stuff, right? That's not a, what would you say, is that a sustainable model? No, because what do people in offices do that are going to drive IT folks crazy? They're going to move. Like, I have this personal belief that if you work in a business, businesses are like, hey, we haven't irritated the IT department for a while. Let's all move. And then be like, oh, the synergy will be better. But then we have to have the IT people come in and start reconfiguring crap because we just decided we needed to move. That's my little opinion on it. Maybe there's real reasons why people move. But that ends up being one of our fun things we get to deal with. Other ways, like there's other really obvious ways of subnetting stuff. So DSU has some really obvious ones. We do it by building because that just makes it easier for us, right? It's challenging, you could say, to try to span a subnet across multiple physical locations when each segment of our network has little uplinks going to them and whatnot. So we can make our network a lot more efficient here by doing it by building. The place I worked for actually went further, and since it was big enough, they did it by building and then by floor and then by zone. So we would have a subnet for like, I was like 5A4 was my building, my zone, and then like my section within the zone. New working really, like if you hit true cubicle farm, I refer to my office as the cubicle farm. There's 4 cubicles down there. That's nothing compared to like you walk in and it's cubes for like off into the horizon. There's just cubicles. So you have to have those little segmentations to just find people. And then people post their pictures on the outside of the cube with a name tag, so when you try to find them, they can actually find you. So anyway, yeah, we were configured on our own little subnet in there. Well, not little, but our zone had its own subnet. That way, if there was a network outage, it only impacted like this random group of people here. So that's another fun little way of doing it. The other way that starts to get even more challenging than just figuring out by department is by privilege level. So there's obvious subnets that we would put in place for us as like the firewall managers and stuff that can access the admin interfaces to things, right? Does the accounting department need to access the router's administration interface? The bean counters are doing a little SSHing into the core router kind of thing, right? No, that's not going to be a thing. So we could have privilege level sort of subnets. So there can be folks that, let's say we have a data entry group. So we could actually, this would be really pushing it, but you could configure like a SQL server or a database server connector that was write only so that the data entry folks could only access that over the network. That'd be really going deep, but you could do that. But then there is one obvious sort of need privilege sort of category we can do is people that just want the internet, and that's people that like guest network, right? I just don't want to use the data plan on my phone, so I leech off of your guest network. So, yeah, we end up with lots and lots of different categories, which they're all kind of a wash. It just depends. There's not like one set category. Same when we come to DMZ. What is, I guess I'll come back to DMZ. So when we're talking about a DMZ, what is the DMZ doing? How many of you have heard of a DMZ? How about that? What's DMZ stand for? Demilitarized zone, yeah. Why do we call it that? Yeah. So from a military perspective, what is a DMZ like when we're talking about North and South Korea? A place you don't want to be. Yeah, probably. So in those instances, we have these two countries with these borders that they're like actively guarding. Well, to an extent, and North and South Korea are probably a little close for this to happen, but to an extent, the DMZ is like that space in the middle that's like not really one side or the others. There's not military people standing there. There's military people next to it. But so the DMZ is the area where like we allow kind of free exchange of people or whatnot. I don't know. I'm starting to dig now in my military DMZ. So in the case of a network, our militarized zones are all of these areas locked down by a firewall that we don't want the internet to touch. So when it comes to, this one thing that we're going to talk about is looking at traffic inside of the network moving back and forth, because there's lots of nasty going on inside that is not traditional. So if you go get like the old school firewall book somewhere, they're just going to talk about filtering traffic for the internet. And then they're going to say once the traffic is inside your network, it's great because the firewall filtered it. And we know that is not the case now, right? So either way, no matter what, we have rules about who can touch what. So external users can't touch things. This is our traditional firewalling logic, right? We don't want the internet to directly touch our SQL server, right? What are we going to have inside of our SQL server? What is SQL storing for us? I'm sure everyone took the database class and loves it. Everyone's SQL aficionados, right? Getting just so many blank stares. So it's a Tuesday. What do we store in our database servers? Like what kind of data does an organization put there? User accounts. That's going to be in there for like running some sort of application that you have to sign into. Usernames, passwords are going to be there. What if we're running a shopping cart? All product information, items, price, pictures, inventory, customer credit card numbers because they click save my credit card, stuff like that, right? Just casually that as well. So do we want the internet to be able to touch that? Even if we think we've secured, like, oh, I make sure to patch that SQL server running Windows. I patch it all the time. Is that going to really mean much to you? No, because I patched it, and thankfully I'm running custom code on it so that when people start to query it, well, my code is perfect and the permissions are immaculate, right? How many organizations have told themselves that and then lived to regret it? They're like, well, we wrote this custom application, and we made our own security model inside of it, and then someone broke it, right? So we don't want the internet to be able to reach out and touch these things. So when we talk about firewall rules, what we're actually looking at is the context of who initiated the connection. Because when we start making a firewall rule, the workstations on our network, are they exchanging traffic out to the internet? Are you in here exchanging traffic out to the internet? At some time, is the internet sending traffic back to your machine? But who initiated the connection? You did, ideally. Because if the internet tries to reach out and initiate a connection to you, what is DSU's firewall going to say? Should say no thank you. Should. Or even a step further, what should your host firewall on your computer say if it receives unsolicited traffic from the internet? It should also say, no thank you, I didn't ask for this. When you send a GET request to Google and Google responds back with their web page, did you initiate that? Yeah. So that's all the context of stuff. When we're talking about touching, it's who initiated the touching. So the internet should never, or external people should never, ever, ever be able to touch anything inside of our network, except for a few explicit things. There's the flip side to the no touching. There are some things we do want the internet to be able to touch, right? So DSU has a web server. Does that receive unsolicited communications from the internet? Yeah. So when I am at home and I type www.dsu.edu, did our web server solicit that? Who initiated that? I did. Yeah, the client out on the internet did. So there are some things we have internet accessible that we have to deal with, right? So should this web server that the internet is touching, should it be sitting next to the database server that no one's allowed to touch? No. It should not. So that's where we end up making a DMZ. So the demilitarized zone is where the subnet, essentially, where we'll put that web server, saying, hey, this is a subnet of our network where the internet is touching. It's initiating connections to these machines. We need to up our patching game on these computers because if Microsoft has an O-day discovered against them, what's a 0-day or an O-day? It's a vulnerability that's been discovered that is, it's unpatched, yes. So it's something, when someone comes out with a 0-day vulnerability against Windows web servers, that is a time for you to clench your teeth a little bit, because if you have a Windows web server and there is a publicly exploited 0-day vulnerability, is there anything you can really do? No, there's mitigation tricks that we have that comes with having a fancy firewall and paying an expensive license fee. But otherwise, it's really hard. So how often does this happen? So about a year ago, there was, I should actually look to see, it'd be IIS crash with a number, something like that. Nah, that's not gonna go. Well, basically, about a year ago, I'm pretty sure it was, there's actually a vulnerability in IIS, which is Microsoft's web server, that if you just sent this exact number to it, like when web servers have their conversation, post and get and stuff like that, if you just said post this number, IIS would just explode. It's a little more complicated than that, but that's basically, yeah, and I don't want a list of all vulnerabilities with them numbered. Oh, this is an old one too. Oh yeah, 1997. Good grief. Well, anyway. There's some sort of vulnerability out there. This was patched. But so what we would do from our firewalls is look for, when we get into doing deep packet inspection, we would actually look at normally all the normal firewall stuff, but then we would also look for this particular number. And if someone was sending that number to one of our web servers, then we would drop the packet. So anyway, got to keep stuff from touching. That's a big thing. That's where we have our DMZ sitting there. So, context of firewalls. The direction is really, really important. So, we don't want the internet to ever initiate touching with database servers, workstations, stuff like that. We need to let it touch an email server, web server. But on the flip side, there are, and this is usually the one that's missed in most organizations, is what we'll call, when we have internal traffic, or outside traffic coming in, the word we refer to that as ingress. It's incoming. So me at home browsing DSU's webpage, that's ingress traffic as far as DSU is concerned. The outside traffic is coming in. The flip side is egress. When you go out to Facebook or whatever, that's egress traffic. That's internal initiated stuff that's going out. So your workstations, they can touch the internet, right? They should be able to typically. This is where we have egress traffic going on. Does an email server need to go out and touch the internet? What would be an instance where an email server would need to reach out and touch something on the internet?
Sending an email.
It's delivering an email, yeah. So when DSU's email server wants to send a message to Gmail, it needs to go out to the internet and talk. These guys, does a database server ever need to initiate a connection out to the internet? Or a web server or a file server? Should my web server be browsing someone else's website? Probably not, right? So this is typically where we get egress firewall filtering. So this is where we block inside stuff from going out. If we see any of these trying to go out to the internet, it's probably one of two things. Guess what the most common thing is? Especially if they're running Windows. No guesses as to why these computers would just start to initiate connections out to the internet? So Windows updates, that's the easy one. That's a really common one. It's the one we expect. Also, Windows comes packed with many other things that even on... Oh, dear. And even better, this is an update for the updater. Oh, boy. And we're going to do what all users do and say, not right now. That's perfect. So there's updates. In Windows, when you look down on the bottom corner by your taskbar, your little network icon indicates whether or not you're connected to the internet. Or if you haven't noticed that, connect to like a wireless router that goes nowhere, and you'll notice the little icon down for your wireless will be different. How does it know? Like, how does Windows actually know? Because it goes out to a stupid web page hosted by Microsoft and just tries. That's another one. There's also, when we come down to the world of certificates, so we'll get into certificates in great detail, but there's one part of certificates that's really can be important called CRL, which is a certificate revocation list. So if I've issued out a certificate for proving identities and then it's compromised, I'll revoke it. But the only way for your computer to know that it's revoked and invalid is to go get the update from me. So that's another fun one, that in the background, all the time, Windows is just going out and trying to connect to the internet. So doing this, preventing inside stuff from going out to the internet, is really, really, really hard to do. Because Windows is constantly trying to do it and thwart your efforts to block it. The other part is, do you suppose any of those services run on just a particular batch of IPs? Or can we just go figure out, like, oh, this is Microsoft's subnet of IPs. We'll just let them talk. No, what does Microsoft now do? They didn't like 10 years ago. But what do they now do that makes this impossible? Which most companies serving lots and lots of stuff on the internet also do. When you go to google.com, are you getting the web page from a server in California? No. Where are you getting it from?
ISP.
24.220.112.157. Any guesses as to who owns that IP address? So let's look up, I don't know. Oh, there we go, CQ counter. That's my favorite one. So Google's IP address, type it in, SNU, away we go. Mid-Continent. So does Google just have a data center running in Sioux Falls and Mid-Continent happens to be their ISP? No. Why did this come back as being from Mid-Continent? Yeah, there's probably not necessarily Midco running a cache. Probably Google or one of the content delivery networks has put a cache inside of a Mid-Continent data center. So when you're starting to hunt down, why is this database server connecting out to this IP address? And you start to hunt down, like, well, what is that IP address? And then you find out it's my ISP. So then you either A, have a healthy dose of paranoia, because someone has compromised my server and trying to get data out of my network, or B, it's just Windows being Windows, and Microsoft, being like Google, just put a content cache there, and you're just stuck with it. So that's where these become a huge, huge challenge. So when you sit down to actually do it, it is a really, really big piece. So we talked about who initiated the connection. That's a big deal. We'll come back to criteria. Next thing I want to do is like the actual layout of stuff. So if you don't have Visio, which I'm on a Mac, so I don't, Draw.io is a really cool alternative. And I don't know how they make money off it or keep it alive, but I just go with it. So when we're actually doing the layouts of our firewalls, this is a common thing that we would see, I would say, in the past, but we do still see it. So we'll plug in, see what we got going on. Why do we need a router on the edge, assuming we're a really big network? So it's just possible that this router might be connecting to more than one way to get to the tubes, right? So that's why we put a router there. To an extent, this kind of would actually mirror DSU. We have multiple connections to the tubes, so we have a router sitting here outside of our firewall. So we do a switch, and then, yeah, here we go. See, I planned this in advance. We would plug in the web server to that. But then here what we would do is we would plug that switch into another firewall, which would then plug into, boop, and this actually, now that I'm thinking about it, is kind of going a little bit crazy. Oh, because the art of me dragging the shapes around is probably lost its effect here, hasn't it? And then we'll do something like this. There we go. All right. So this is a really common, kind of old school way of doing this. So it's cool because we basically take our DMZ. We have like our path to the tubes, right? So our DMZ ends up sandwiched in between two firewalls. So the restrictions in place on this firewall versus the one down here, how are they different? So one is handling direct raw internet, and this one, I suppose, like, can these users still get out to the internet? Yeah, the router's going to say, like, hey, just bounce the traffic up through this path, so they can still get out to the internet. So life isn't too rough there. our web server or our restrictions based on this firewall. So this is kind of some cool things that this does for us. This firewall can take out the majority of the traffic, right? This firewall knows the majority of the junk. It's handling all that unsolicited junk. Is this one going to see a lot of unsolicited junk? Whoops. Over here, this internal firewall. What is this firewall basically going to do for any traffic coming from the top down? Would it let it through? Would it let traffic from the tubes coming down through?
Oh, the first firewall didn't block that?
It depends. Could. Maybe, maybe not. What's this firewall probably going to explicitly do all the time? It's probably going to take any traffic coming from the outside in and drop it. It's going to say, hey, no one can come from the outside of me. So when this firewall looks at it, because it's going to have this WAN interface right here, it's going to say, hey, anything originating from this interface, I don't want. So that's going to keep this internal network pretty secure, correct? But what's the problem that this does not protect against? So we could still do outbound filtering, so we could say like, hey, Department A, we're not going to let you get to Facebook or something like that with our firewall. We can still block outbound stuff, right? But what if someone in Department A gets an infection on their computer? Is there any filtering going on inside of this whole internal network? No. So the only time that at least from the firewall sense, we'll notice anything going on is if we just notice fishy stuff crossing over it. So that's one reason, or one area where that gets a little sketchy for us. The other one is Microsoft has not made, let's say this is Windows, once again. So we can actually attribute a lot of bad network layout stuff to Microsoft, our friends there. Let's say we're running Active Directory. Okay, so in Active Directory, let's say this machine is connected to Active Directory. What does that machine need to talk to in Active Directory? It needs to talk to a domain controller. Do we want to use the domain controller that all of our users are logging into and just park one out here? Probably not. So we're left with our DMZ network either has its own Active Directory domain all to itself, which that's one option, and then we do park a domain controller out here. Or through this firewall, we now say, well, we're going to block all outbound stuff except for like the web server. We're going to allow it to go in and talk to the domain controller. And then we're kind of losing our efforts of having a DMZ in the first place. So that is one way in which we can lay these out. Now, what I would say is probably more common, or starting to become more common, and it all depends on the size of the network, is eliminating this whole part. Boop, we'll scooch that guy over. I suppose I need another switch, don't I? What's the perk of this method? We only have one firewall we have to deal with, which that can be good and bad, right? What's the good part about only having one firewall to deal with? The context of all this is way easier to see. Like if we're trying to allow, I don't know, say someone to talk to the web server, there's just one device for us to log into, as opposed to, well, are they coming from the internet or are they coming from the inside? So it's one device to log into, so that's a pro. There are cons, though. Well, the other pro is this firewall, again, knows the context, so it can start to monitor all the goings-on between all these devices, right? So we can see, we get the full picture of what's really happening. What We also eliminated a router. We needed one less router inside of our network, so that maybe is a pro. What have we probably done to the cost of that device, though, of that firewall sitting there? Yeah, we've now taken the firewall and put a lot more, what would you say, weight on its shoulders. And it's one thing if you have, like with our router, if we have a 10 gigabit network interface on it, how fast can we roundabout say the router can route packets if it has 10 gigabit interfaces? Should it probably be able to handle the speed of its interfaces? Probably, in a roundabout way. So, how about firewalls? Are firewalls looking at more information in a packet than a router is? What's really the only thing in a packet a router is looking at? Oh boy. It's just looking at IP addresses, right? That's all a router's ever looking at are IP addresses. So, when we take firewalls, are they looking at more than IP addresses? Yes. So in this particular firewall, this doesn't tell us. Well, I'll just go to one that I know off the top of my head. Well, I'm guessing that this has 1, 2, 3, 4, 5, 6. Is that right? 1, 2, 3, 1, 2, 3. 6, 12 plus 1, 2, 3, 4, 12 plus 8. So this has 20, we're just going to say gigabit interfaces on it. When we look at how much this firewall can actually process through it, it can only do 4 gigs a second. So are we going to load up all these network interfaces with stuff? No. Well, assuming not full traffic anyway, right? So that is where firewalls kind of bring us down a little bit, because since they are looking at more information, they're not as fast as a router is going to be. So that's where the cost of your firewall goes up quite a bit. So if we look at this firewall, this one is super exciting because it can do 10 gigabits of throughput. The specific thing, app ID, anyone know what this is doing? Or anyone heard of this before? We'll talk about it in class. So basically what this is doing is like looking to see, is the traffic on that port what I think it should be? So if you see traffic on port 80, what do you think it should be? What runs on port 80? Web traffic, right? So if you're looking at like the data inside of the packet and you see it's SSH, should that throw a red flag? Maybe, maybe not, probably. So that's what this is actually doing, is it's looking at more than just ports in the packets. But anyway, 10 gigabits of firewall throughput. Well, this firewall actually has multiple 10 gigabit interfaces on it. So what we're basically saying is this firewall can't actually handle the speed of its own interfaces, or it can handle the speed of one. So that's a thing with firewalls. They start to get more and more expensive with the more and more traffic we have to deal with and play with and all that good stuff. So, a couple different ways we can lay out stuff. We then allow and deny really basic stuff. What's the criteria firewall looks at? When it's sitting there, see the kitty is happily protecting, even though that just looks like a modem, but still. What criteria is a basic firewall going to look at? IP? Which part of IP? Like what other details about the IP?
Ports.
So there's ports, IPs and ports. So now we need to double those. When we talk about an IP address, do we just care about where you're going? What's the other thing we're looking for? Where you're coming from. So we end up with, so for the most part, four main things. We're looking at your source and destination IP addresses, your source and destination ports, And then if we actually go a step further, we look at protocols. What protocol at this layer of OSI model are we talking about? There's probably only two for the most part. But there are many others. But yeah, TCP and UDP. Those are our two. I did hear you. So apparently I have good ears, or the acoustics of the room are really good, so I can hear the whisper. So yeah, for the most part, we're looking at, is this TCP traffic on port 80, or is it UDP traffic on some weird, like port 53? There are others, or there's some weird ways that flip this. So if we look at, what's ICMP? What's that? Ping. Ping does not do ports. There's no ports to ping. If you see something that says, I'm going to ping port 80, it's sending a SYN packet. It's not sending an ICMP packet. So there's ping. That's a different protocol that we could be dealing with. There's also like GRE and AH. That's weird VPN stuff that we'll talk about at the end of the semester. So those are our criteria that we've got. So when we start to look at these, and this is, I rant on this, and some of you may roll your eyes, but these are like the most common mistakes and troubles that we have with understanding stuff. So when you go out to a connection, your computer and your firewall, like at the edge of DSU, is going to remember stuff about that connection. So it's going to know your internal IP, so it's going to know the source IP address. It's going to know the source port number. And then it's going to know the destination IP address and the destination port number. 3 of these are kind of predictable. So can we figure out what your IP address is? Yeah, I can probably predict that if I'm the firewall and be like, well, it's probably going to come from this range of IP addresses, right? So for you all, it's going to come from like 138.247.90 to 111 or something like that, because you're on the student subnet. So we can figure out your source IP address. The destination, I mean, we can't like predict what our user is going to do. That'd be nifty if we could. We hooked everyone up to like a mind control machine. But, so we can't really necessarily predict that, but the user is going to provide that to us, right? And we're going to know, on the flip side, if we're firewalling stuff, can we block Facebook's IP addresses? Yeah. So there's we can figure that information out. Can we figure out ports? Yeah. We can figure out or determine if we want to block you from getting to Facebook, I would block these IP addresses and maybe these ports. I would probably just block the IP address and say all ports. But what's port 443 going to block for us? Yeah, encrypted web traffic. So HTTPS, or a lot of times we say SSL traffic, even though we hope it's not SSL anymore, but that's still what we say. So can we predict this? The port number on your computer. We can't predict that. What is the purpose of this port number, by the way? Why, when you send out a packet, does the packet come from a source port? You know, computer architecture land, what the point of that is? So does your computer have more than one process that's talking on the internet? Safe to say, yes. Does your computer, let's say I want to watch the world burn, and I'm going to do this. See, notice this is going to be a tricky thing here. Not specifically just use Firefox, but look at this. I have 2 browsers at the same time open. So I have 2 different processes running on my computer that can be initiating traffic out to the internet. So let's say I go in here and somehow type like google.com there, and let's say, well, let's do something tricky like scooch that over there, scooch this one here, and then go google.com here, and then just really quick hit enter on both, even though I didn't really quickly hit enter on both. How did we keep the replying packets from Google separate? Somehow we had to make sure this Google is different from the one over there, right? I mean, it's the same web page, but we receive different packets back for it. So the point of it is, when you look at netstat on your computer, and we see many things that I am currently connected to, what each one of these particular port numbers, and when you run netstat on your computer, you'll find that they're all unique. What these port numbers are signifying to us is what process to hand it to. So when Safari sent out a packet, what Safari really did was said, hey, I need to do a GET request for Google.com, handed it basically to like the network subsystem of my computer, which then sent it off to the network adapter and sent it out to the network. And I just sat here and casually waited, and we received many packets back, but when I received a packet back on port, I don't know, probably this one, 53176, it said, oh, that's the port that I assigned to Safari. So I'm going to take that bit of data that I got from the packet and hand it to the Safari dot whatever bin process. I don't know what Safari's process name is. So that is why there are port numbers. You have lots and lots of stuff communicating, and this is a case of all the connections that my computer currently has, which is a hearty amount. So when all this traffic comes back in, somehow we have to be a post office and say, well, who do I hand this chunk? I just got a chunk of data from the network adapter. It was sent to port whatever on the computer. What process do I actually give this to on my computer to understand this data? So that is why we have source port numbers. The magic thing, can we predict them? No, we can't predict them. It's not, they're like made up randomly on the fly. So generally speaking, these are called ephemeral ports, yeah. When we're going through and doing source ports, usually a firewall is going to say source port and not ephemeral port, but that's what they're called in the context of if you're writing an operating system, you're going to call them an ephemeral port. So when we look at this, source IP address is telling us like what computer initiated the traffic on the network because of its IP address. And then the source port is actually sort of telling us what's the process on that computer that initiated the traffic. So then destination IP address, these are pretty standard, right? Where are you going and what port are you connecting to? So that's, like I said, is going to be the part that's weird to get mixed up. So when we're making firewall rules, we have three choices of stuff. Three choices of what we can do. We can allow the traffic, we can drop the traffic, or we can reject the traffic. So going back to our networking, probably networking 1 days, what's the difference between allow, drop, and block? Yeah.
Drop doesn't say anything back, and Jack tells us that it got rejected.
Yeah. And then allow is really obvious, right? Allow is like, oh, yeah, carry on. Dropping the traffic is like the text message that never gets the reply. Because we've all lived in that game, right? You sent the message and then you just get ignored. So that's what drop's doing. When we configure our firewall to drop traffic, we send a packet off, it hits the firewall, and the firewall just goes, nope, and it just deletes the packet from memory and no record of it ever exists again. Whereas when we block or reject, we specifically send what back? Assuming it's TCP, anyway. So in the world of TCP, we have our three-way handshake, which uses what flags? SYN and ACK. What are some other flags that are inside of TCP? FIN is another one. It's not the one we use in this instance, but it's very similar to FIN. FIN is a happy packet. FIN is like, well, have a good day, right? That's when we see a FIN, that's what we're saying to each other. That's what the computers are doing. They're graciously bowing out of the conversation. There's also a reset. What's the reset do? Oh boy, maybe we need more Networking 1 review. So the reset packet is like the middle finger packet. It's like, nope, I'm not having your business. You got to start over with me. So if we do block or rejects, what we're doing is we're going to reply to traffic we don't like with a reset. Why would we do one or the other? Why would we do drop? That's the easier one. Why would we just silently delete the packet?
Not let them know what the rules are.
Yeah. We're like, by not giving out information, we're keeping ourselves in the dark, right? So if someone grabs a random DSU IP address and sends unsolicited traffic to it, we're going to just drop it. Now that's going to tell the person one of two things. Either A, that IP address isn't in use. It doesn't exist. It doesn't do anything. That's one thing it could say. So you're trying to attack a system that just isn't there. Even though our IP space is 100% allocated out in the world, are there IP addresses that are unused? DSU has about 60,000 of them. We have lots of IP addresses, and they all go to us, but there might not be a computer on the other side using it. So there's that. Or when we drop the packet, that could tell an attacker they have a firewall that's just dropping the packets. So reject. Why would we? I have anyway a particular reason why I set up rejects on firewalls on occasion. Any guesses? It's really, it's like the printf of programming in CSC150. After you get far enough along in programming, you learn about debuggers, and you're like, hey, this is cool. Instead of doing 1,000 printfs in here, I can just run a debugger. So sending resets back is kind of like the printf inside of there. If I'm troubleshooting something, and I'm saying, why is the traffic not getting through to the server? I will go start switching some of my block rules to reject rules and then run Wireshark on my computer. Because can I learn anything if I'm doing this? The package just goes off into Neverland. Whereas if I am troubleshooting something, have troubles or whatever's coming up, and I'm getting a reset back, then I'm like, oh, it's that one. You're my guy. Assuming that firewall rules had a gender, right? So that's where I would do those. So this is the last thing we'll do today before everyone dies on me. So our general firewall syntax is going to look like this. There's some sort of action. So what was our action that we could do? There were 3 of them that I just talked about. I don't know why I'm struggling around on this thing. So where am I at here? Allow the internet to access our web server. So I want the stupid bullet thing to turn off. There we go. So allow the internet to access. What's our action going to be? Allow. What's the source IP address? So allow the internet to access our web server. Do we know the source IP address? What is the source IP address of the internet? We don't know. We don't know who it's going to be. So that's where we would say allow star. Or some firewalls don't like stars, so you go 0.0.0.0/0. The elusive /0 subnet, which, configure that on your router and try to route traffic or send out a BGP update with that. That'd be cool to see what happens. So we don't know the source. We don't know who's going to come from. Do we know the source port? when we are running DSU's web server, do we know the source port that all of our operating systems are going to arbitrarily choose when they try to go to our website? No. Can you really ever predict that? No. So that's going to be allow star star. What's the destination IP address going to be? Where would we find that information? Or whatever the web server's IP address is. So I'll just do that, which I think is actually DSU's web server. What's our destination port? 80. There we are. There is our firewall rule to allow folks to go to our web server. There's lots of other complicated things that will come up with this, but for the most part, to finish my ephemeral port talk, because I'm going to just skip ahead. Yeah, you want to see the picture? So there are many reasons why we can't ever do anything with ephemeral ports, because different operating systems force different ranges of ephemeral ports. So if you have old computers, Windows XP is like hard-coded to use 1024 through 4999 as their ephemeral ports. That's what the operating system is built to do. If you run Server 2008 and install Microsoft Exchange, it's going to be that. Linux uses this. Is there a standard out there for what ephemeral ports should be? Did someone say, like, hey, when you want to do ephemeral ports? Well, let's look at the, there we are. The Wikipedia page. So IANA says use 49,152 to 65,535. Does anyone follow that rule? At least Linux is close. With most Linux kernels, it's roundabout close to the ephemeral port range, and with different kernel versions, it updates. So this number could be different now. I don't check this every time, but Microsoft has basically never followed the ephemeral port rules. They've always just done their own thing, which is cool. It's a good time. So on that bombshell, with the weird pink hairless cat thing, we'll call it a day. Oh, there was, I forget, one. Does anyone have any homework questions that I meant to talk about? No questions assignment. So actually I had a couple different people email in questions, so I'm just going to in an effort to make sure everyone is on the same page and that I don't answer questions in one class section and not the other, because that would start to get annoying, because then I'd sit here and be like, well, I told you, and you'll be like, no, you didn't. So when we come in here, the question I was just about powering off the machines. So let's look at this one. This one's not going to really show it, but when you go in and just shut down, like inside of Windows or something like that, and just go shut down the machine, that will shut down the machine. It's not going to use processor and RAM and stuff like that, but it's going to look weird to you because the status is going to say partially powered off. How many of you have probably seen that message quite a bit? So the reason why that message is still, or says that, and it's not just powered off, is there are still resources allocated because the network adapter is still plugged in and the network is still exists. There's actually a VLAN literally existing in the IALab core. So to have your machines all the way powered off, if you come over to this tab and just hit the stop button, that will completely shut down everything. If you have partially powered off, though, I'm happy. That's fine with me. It's not a big deal. I have many VLAN IDs, so I don't worry about that so much, as opposed to RAM costs a lot more than me configuring a VLAN ID. So That's the story behind partially powered off and powered off. Also, some of you might really win sometimes and get inconsistent state. Then you need to email me. That usually it happens because you were dinking with stuff and you're like somehow weirdly turning things on and off quickly, and this web interface thinks that your machine should be shut down, but it's actually running. So it like locks you out of it because it's like something's out of sync, something's wrong. There's also sometimes if you get like a yellow shield on the machine, if you come over here, there will be under status, it'll say needs action, and it'll be a link inside of there. That usually happens when you're installing or you put basically a Linux installer in, and Linux locks in old school computers that had CD drives. The Linux installer will lock the CD drive in that when you press the button to eject the CD drive will be like, I was told I'm not allowed to eject. So it won't eject the CD. So, but then what Linux does is when it's done, it explicitly ejects the CD. So somehow in virtual machine land, it doesn't like do it in the right order, because when you finish like installing Linux, or it just happens sometimes with stuff, the installer will say, okay, eject the CD, and VMware will be like, but you told me I'm not allowed to eject the CD. So then you'll get the little question saying like, do you want to override the lock on the CD drive and eject the CD? Anyway, when you see requires action right here, just click on it. It'll be a little link, and it'll pop up and ask you a yes or no question. So that's all I have.